So now I would like to introduce Terry. I can call you that, right?
Yes.
Okay. Terry is going to give a talk tonight, and her talk is Out of the Ashes and the Story of Recovery after the Landscape After Wildfire. She's got credentials that are that long. MS from Kansas State, but just know she knows what she's talking about, okay? And I want to just go ahead. In 1977, she witnessed the destruction of the La Mesa fire, which burned 15,000 acres. So a lot of her experience is pretty hands-on. So you can brag all you want on yourself, okay?
Okay.
This is not a formal group. So this is Teralene Foxx. Go ahead.
Okay. Well, since you said I could brag a little bit, I'll tell you a little bit about some of the publications I brought, so that if you're interested in them, you can look at them. Some of them you can get electronically, and some of them we have for sale. First of all, this is my children's book. It's called The Forest and the Fire. When I was doing my fire research, my children had to go with me. And when the Cerro Grande fire burned in Los Alamos in 2000, my oldest daughter, who is a poet and a musician, wrote a poem about fire. They had experienced it, they knew about recovery, and so she did the poetry, I did the illustrations. This book is produced by the Historical Society in Los Alamos. It's $6 or 2 for $10 if you want a bargain. The other publications that I have, I spent the last 37 years studying fire. Mainly the La Mesa fire, and I'll explain a little bit more about that. I have 3 publications related to that. I just bought 2 of them. This is my main report that came out last year, and then this is about fire effects on plants in the Jemez Mountains. And it applies many places. After the Cerro Grande fire, I worked at Los Alamos National Laboratory. I had just retired in December of 1999, and in 2000, the Cerro Grande fire burned through Los Alamos, and the laboratory brought me back to write a document that would help people have hope. And so this is the document I wrote. It's about fire and fire in the environment. You can get it electronically, but I have a couple copies with me. They gave it to all 20,000 employees. Right after the Cerro Grande fire, we were all evacuated, and so there were lots of stories of people helping, people, what happened to them. And so immediately after, I wrote a book called Lest We Forget, because I figured once we got into the FEMA and all of that stuff, we'd start forgetting the good things that happened, the way the community came together, the way people helped each other, the way people in northern New Mexico helped us. So after 10 years, I'm the president of the Pajarito Environmental Education Center, and president of the board. We do Earth Day. So Earth Day 2010, I compiled this book, which is looking at the same people that I wrote about right after the Cerro Grande fire, 10 years later, to see where they were in their journey. The unique thing about this is that there was a teacher who had there was one school where 40% of the children lost their home. And that teacher spent a lot of time trying to help those children heal. And one of the ways she tried to help them heal was for them to write their story immediately after the fire. And so she had their essays. And so she contacted those students, said she had their essays they wrote immediately after the fire, and then I contacted them and interviewed those students. And so there's this perception of what it was like when you're a fifth grader versus what you are like, where you stand as a college student. The other thing that I'll mention is I wrote this book on the flowering plants of southwestern woodlands with Dorothy Horde. It is out of print. We're revising it, and it'll be out sometime probably next year. So let's get some lights. Okay. Okay, we're going to see if this works. Oops, went too far. Oh. All right, I'm going to just do where I'm at. Okay, thank you. I want the first one. All right, I won't touch it after that. Fire is a natural part of the environment. Humankind, for a long time, every culture had something about fire. In the Greek myth, Prometheus lived with the humans, and he wanted humans to have fire, and he tricked Zeus, and he was punished for it. In India...
Is your microphone on there?
Oh, you can't hear her? It's not a microphone to hear with, it's a microphone that goes in.
Do I need to speak louder?
A little bit louder.
Okay. All right. In India, there were a god of fire. In Native American cultures, there were all sorts of stories related to fire. And usually it was a trickster of some sort that would trick somebody, or in the case of Coyote, he decided to trick the hornets who had fire. And eventually, he gave fire to the people through the sticks that you rub together. In the Pacific Northwest, the raven was the trickster that gave fire. So fire is something that has existed, and human beings have talked about it in various ways. It's both a friend and a foe. Now, scientifically, we know that there was fire in the environment on a frequent basis. And we do that through fire scar dating. This is okay. The tree that's right there that has that triangular, that's called a cat skin, a cat face. All this technology. Okay. All right. All right. This is called a cat face. If we cut that tree down, we can look at the rings and we can see fire scars. We can count the number of rings between the fire scars, and then we'll know what the fire interval or fire frequency was in an environment. I have a copy, I have one of the cross sections right here that you can come and look at. So what we know from this kind of a study, that before 1900, the average fire interval was once every about 5 to 10 years in the Ponderosa Pine. But after 1900, it was more like 40 to 80 years. If you look at this, this is one fire-scarred tree that the center was 1637, and it was cut down after the La Mesa fire in 1977. And you can see that it had a number of fire scars on that particular tree. The ones that are in yellow mean that there were multiple trees in Bandelier that had the same date on the rings. So we could say that 1806 was probably a fairly large fire, as was 1842. But what is significant here is the last major fire scar was 1893. Then it was not until 1965. So you can see the difference in frequency. The average before 1893 was 10.5 years, and after 1893, 72 years. So why did this happen? How come 1900 is sort of a turning point? That is because in the early part of the 20th century, the Forest Service was started. About that time, there were some very large, disastrous fires that killed people. So one of the ways they thought they could treat it was to stop all fire. And so they had what is called the 16-hour rule. In other words, the fire had to be stopped within 16 hours. So you never had a very large fire. It was always a small fire. Another thing that happened particularly in the Jemez Mountains, and my model is, of course, the Jemez Mountains, because that's where I did my study. But the next thing at that period of time, which is true in various parts of New Mexico, was homesteading. And people came into areas, and when people come into an area, they don't want to live with large fires. So that contributes to it, plus they have animals. One of the biggest changes in New Mexico was that domestic animals were brought in early on, sheep and cattle. Sheep in particular, the way they graze, they pretty much denude the soil, and Ponderosa Pine likes a open environment in order to germinate. At one time, there were over 1 million sheep in New Mexico, and in the Jemez Mountains, there were 50,000 sheep on the Valles Caldera. That picture up there, the top picture, is one taken by Bailey in 1906. This was a repeat photography in 1997. And you can see the change that happened after the sheep were taken off. What happened after that, when the soil is denuded, there was a wet period, and then we had a flux of young pines that came up. And so you get various forests that look like this. That kind of a forest is not a healthy forest. First of all, most animals can't live in something like that. Secondly, it's too dense. The trees are not going to grow very big. They're laddered, and I'll talk a little bit about what happens with that. Oops. The other thing was logging, and logging contributed more from the slash that was left behind. So what we have as a result of fire suppression is what you see in the bottom here. This is what we think a more historic forest would look like. No more than about 100 trees per acre. Not like this. In some places in Bandelier that I studied, there were 600 trees per acre. And that comes about because of the length of time that there was no fire. What a ground fire does is it cleans out the underbrush. It keeps the forest from being laddered like this. So if you have a fire come through here, it goes up into these little trees, up into these trees. It becomes a crown fire, and when it's a crown fire, it moves extremely rapidly. Here you will see that the trees are not laddered. The bark of the Ponderosa pine is very thick. It's a fire-adapted species. It means that when a fire comes through, because the bark is really thick, a ground fire, it will just burn maybe a cat face, but then it won't burn into the crown of the trees. Oh. So this is what I'm talking about, a very dense forest. There's not much there for animals to eat. What they think historically a forest was more like little clumps, a mosaic of a meadow, clumps, and then a meadow. But in many places in the West, this is what we have. And this is the condition of our state forests. There are 192 million acres of Forest Service administers. 73 million of it are at risk. Tens of millions of acres are dying from insect and disease. When trees are that dense, they can't fight off disease. The General Accounting Office says 1 in 3 forest acres is dead or dying. That is either because of insects, disease, or the influence of fire. Now, as I said, before 1900, the type of fire we believe and pretty much know happened was these were low ground fires that were cleansing fires. They weren't crown fires. But the thing that's really disturbing is that over the years, the fires are getting bigger and bigger and bigger. In 1977, when I studied the La Mesa fire, it was the first large fire in the Jemez Mountains in almost 80 years. It was 15,000 acres. In 2011, the Las Conchas fire, in one day, burned more acreage than it then was burned in the Serra Grande fire. The Serra Grande fire was almost 50,000 acres. The Las Conchas fire in one day burned that much, partly because it was so hot and dry. But as you can see, we've had a number of fires in the Jemez, and by 2011, that total acreage for that fire was 156,000 acres. So what you can see with this particular diagram is that the number of fires are not changing over time through decades, but look at the acreages. This is actually number of fires per decade, and this is the acreage. You can see the acreage is going up. So what is another reason for this? We love our trees. We love to live in our trees. We have communities such as Los Alamos, Santa Fe, many areas up here where people are living in the trees. And they do not want to take out their trees. I'm a storyteller, and this is my explanation about what our love is for trees. The most common symbol that you will see in storytelling is the tree. It's usually got a little creature in it. They're bigger than us. They're often sacred trees. For example, the Celts had sacred trees. If you cut down their sacred tree, you weakened them. We love our trees. We anthropomorphize our trees. So when we go in and say to somebody, you need to clean some of this out or you'll lose your home, they don't want to cut their trees. And it's very understandable. But nevertheless, this is what is happening all through the West. People are moving into the forests in great numbers. So the chance of wildfire is greater. The more humans you have, the more chance that somebody's going to start a fire accidentally or purposely. So another thing that makes a difference is drought. How much winter precipitation we have is particularly important because snow stays on the ground, it slowly seeps into the ground, and it is much better than just rains, although rains are important. So this is the amount of snowfall we had in various years, fire years we had in the Jemez Mountains. 1950s was a drought period, and you can see there was only 29.4 inches of snow that year. The average is over 50 inches. The La Mesa fire had only 32.6 inches. The Dome fire, which was in the backside of Bandelier, that year had 43. So it was a much wetter year. But let's look at the years of the Cerro Grande that came into Los Alamos and burned into the community. That year we only had 15.7 inches of snow. The year of the Las Conchas fire, we had only 16.6 inches. This year, I didn't look to see what we've had this year, but I would guess it's probably pretty close to those numbers because we're in a drought. So, the La Mesa fire is where I started my life's work. In 1975, Dr. Lauren Potter and I were asked by Bandelier National Monument to look at the frequency that they should do prescribed burning. Now, prescribed burning is a way of controlling fire through the forest, and usually it's done under very strict conditions of humidity and wind and everything like that. It had been used a lot in the east, but it hadn't been used much in the west. And they wanted to know what would be the frequency that they would need to use prescribed fire. So we had looked for areas that had burned only 10 acres or more that we could go out and do vegetative analysis on. And so we found these areas of different ages. 1960, 1937, 1945, 1950, 1955. And then there was, right next to this site, an area where we cut down a tree and found it hadn't burned since 1893. So we had a plot that hadn't burned for 80 years. We had these various plots, and then in 1976 there was a small fire that broke out in Bandelier. So we had just about finished that study, and the La Mesa fire came, and it burned over all my plots. And I can remember standing in front of my house, and I was just heartsick. I thought, this is the end. I've spent 2 years trying to do research, and it's all lost in the fire. All is lost. Needless to say, I didn't realize it was very serendipitous. I was lucky that that day I was out with the Park Service cutting down a tree to do tree ring work, because people kept saying, Terry must have started that fire, because it turned out to be a good study. So after we went back, after the La Mesa fire had burned over all those plots, I could go back and see what was the status of those plots after the fire. And lo and behold, we discovered that if anything hadn't burned within 20 years, there was complete loss of the crown. In other words, that area was a crown fire. All these areas, 1878, 1937, 45, 1950, there wasn't a standing tree alive. But areas like 1960, 1976, they were amazingly different. So, this is what a crown fire looks like. So I'm going to show you these plots and what they looked like immediately after the fire and then subsequent years. Some of them I haven't been to recently. They're far out in Bandelier, and I don't hike that far anymore. So the first one was the 1893, the fire interval. It hadn't burned for 84 years. Fuel loads were over 20 tons per acre. There were 342 trees per acre. Remember I said 100 trees per acre is the best. Average diameter was only 7 inches. So let's look at what it looked like.
Terry, what's the average when you say fuel load 20 tons?
About less than 10 tons per acre.
Is a healthy
I'll show it to you in a little bit. Okay, so this is what that site looked like before the La Mesa fire. This was actually the site we were cutting down the tree. You can see how dense it was. This is what it looked like after the fire. Okay, the top there is what it looked like in 1977. And then they seeded grass, and that's what it looked in 78. And this is what it looked like 16 years later.
No effort at deforestation?
Pardon?
No effort at planting trees, obviously?
No, this is way out in the middle of Bandelier. Bandelier doesn't plant trees. Forest Service plants trees, Park Service does not. Okay. With one exception I'll tell you about. Okay, this area is 1937. It hadn't burned for 40 years. This is what it looked like in 1977, 1985, and 2000. This is what a ground fire looks like. Now, those were areas where there was a crown fire. Now, this is what a ground fire looks like. It goes along the ground, it burns out the needles, it doesn't go into the crown of the tree. They call it a surface fire. Okay, here the fire interval was 17 years and less than 10 tons per acre. 55 trees per acre, and the trees range from 4 inches to 18 inches. This is what it looked like beforehand. In 1976, before the fire. Come on. All right. So after the La Mesa fire, I went out to this plot and I thought, those trees are all going to die. This was done in 1977. And the next year I went out, and this is what that looked like. And that's what it looked like 17 years later. Quite a bit different than the areas where there was a crown fire, right? Okay. So let's compare. On this side, you have what it looks like with a crown fire, what it looked like after 16 years. This is a ground fire, and what it looked like after 23 years. The difference in the years is partly because these are very far out in monument, so I haven't been able to visit them more recently. Okay, that 1976 plot, 1 year. That actually, the most damage was done by the bulldozer. You can see the bulldozer there. That burned in 1976. The bottom is after the La Mesa fire. And this is what it looked in 2011. Not much different than it looked before. Okay, so one of the things that we did was to look at the trees, and I'll talk a little more about this, but what we found is if an area hadn't burned for at least within 20 years, there was complete loss of the crown. The area of the Serra Grande, much of that area behind the community, hadn't burned for over 100 years. Las Conchas was 34 years from the time of the La Mesa. It burned over many of my, Las Conchas burned over many of my plots again, but it had been 34 years. So many of those areas that survived before were burned. And some of the areas had had a prescribed burn only 13 years before, and I'll show you what happened there. So after the La Mesa fire, what we did is we went back out and set up plots throughout Bandelier, 20 by 50 meter plots, and we were able to then measure every tree, map every tree, and follow them through time. So this is what that particular plot looked like. It was a lightly burned plot. It had a lot of trees. This is what it looked like in 2010. See, the lines mean that those trees were down. And then after the Las Conchas fire came through, it thinned out those trees even more. But one of the things it really did was burned up all this, those down logs. So this is what we did. We went out and we looked at the crown of trees in each of these plots. We classified them as whether or not they had 50% of the crown left, 25, they had mostly brown needles or no needles at all. So basically, my 37 years worth of data is related to that, being able to follow these throughout time. So we followed them from 1977 to 2010. And one of my questions was, what trees will live? If they have no crown, will they come back? Probably not. If they have 50% of the crown, they have a good amount. But what about 25% of the crown? Will they survive? Well, this graph right here shows that in my plots I had 116 trees that had only 25% of their crown left after the La Mesa fire. And in 2010, 63 of those trees were still alive. To me, that was quite amazing. In fact, we had 18 trees here that had all brown needles, and yet some of them came back. So one of the things that's important here is the amount of water that is at any particular time. And I must explain this because after 1977 there was a real wet period. But in 2000, these in the 50s and 2000s were a drought. So we don't have the same expectation that trees will live in a drought that they would with more moisture. But still it's quite amazing what does live. So these are some trees that we planted actually in the 80s. So how many of these trees are going to live? That's one of the questions people always ask me. How many of these trees will live? Okay, so this is a picture I took the other day of that same spot, the same trees. It's thinned the forest a lot. Now, when we planted those trees, it was a wet period. We didn't expect as many trees to live. We actually got a little forest there of over 300 trees per acre. Too many. So when the Las Conchas fire came in, it singed them. But this is much better. So what are the factors that cause a tree death after wildfire or during a drought? A tree dies because it either starves to death or it doesn't it's thirsty and it dies of thirst. The part of the tree that actually is living is the cambium layer. The sapwood, the heartwood isn't. The sapwood still translocates materials. But if the cambium layer is not damaged, and you know in trees, if you girdle them, they're going to die. But if there's a part of the tree that still has good cambium, it will often live. The other factor that will make a difference in whether a tree lives or dies is the type of tree it is. Something like Ponderosa Pine has long needles. So when a fire comes through, the growth material is right in here, and it's protected. Something like this that's pinon, has short needles and doesn't have thick bark, so it dies. Same thing with juniper. Ponderosa pine is adapted. So here's a tree that was burned in the Las Conchas fire. This was in an area that was very open, so it was more of a ground fire, but it did go into the grounds. And you can see that immediately after the fire, the meristematic tissues or the growth tissues begin to work, and you get some sprouting. So I decided, I actually did this morning, I wanted to find out if that tree was still alive. And this picture over here, it was really bad light this morning, but this picture right here is this same tree. You can see it still has a portion of its crown, and it's still living. Now, will that tree live over a longer time with the drought that we're having? We don't know. It's something you have to follow. But when you realize that if there's not water in the soil, the tree is going to close the stomata. When it closes the stomata, it can't photosynthesize. All those things, and the tree will either starve to death or die of thirst. I'm in hopes that that tree will live. Certainly, after the La Mesa fire, trees with that little crown did live. Here's an example of a small tree. In 1977, I went out, I looked at this little tree, and I said, well, it's going to die. The next year, it looked like this. The following year, it looked like that. It was more damaged by the elk and the deer than it was by the fire. So if we look at the amount of moisture after the Las Conchas fire, La Mesa fire, and Serra Grande fire, Serra Grande fire the moisture was very low. And how the survival will be, we're having a lot of trees die in the area. So here's the difference in growth rates before, during the wet period, and the growth rates during this dry period. Even if they grow, they're growing much, much slower. And the other thing that's happening with drought is there are drought-resistant species coming in. In 1998, this particular plot was little blue stem. By 2010, it had converted to Artemisia duncularis, or false tarragon, which is much more drought resistant. Another thing people ask me is how long will it take for those trees to fall? I just wish those trees would fall. And this is what happens 8 years later, and the La Mesa fire, almost all the trees had fallen. It's been about 10 years for the Serra Grande fire because it was so much drier. So how long before they decay? Well, this is what happens when you have a prescribed burn. It takes all those decaying logs and breaks them down. So this was after a prescribed burn, and this is what it looks like the following year. These are called ghost logs. See those little stripes? That's because those logs were laying down there after the Serra Grande fire, like this one. But when the Las Conchas fire came through, those areas burned hotter and more completely than the other areas, and they left ghost logs. This is what the area looks like just the other day. It's much more sterile because this was very hot burning there. So snags. This is a snag that I took a picture of in 1976. Snags that come after a fire will take about 8 years to fall. But it depends on how a tree dies. If a tree dies slowly, the sap hardens and the snag can stand. So this is what it looked like in 76. That's what it looked like in 92. The bottom is what it looked like after the Las Conchas fire. They have pictures in South Dakota taken during the time of Custer, where there are snags they have in those pictures that still exist today. So if a tree dies slowly, then it will be a snag like this. And those are important to wildlife. And I know my husband used to cut wood, and they always liked these kinds of trees because they were called pitch trees. Here's one of my plots, 1978. Look at that little knob there. There it is after the Las Conchas fire. Isn't that amazing? Here's an example of how one tree can burn hot and one can be right next to it and not burn. One of the things we really experienced in Los Alamos, and you'll experience if you're in an urban area that is burned by fire, is there's a great deal of grief. There was a great deal of grief for people who lost their homes, and that was something that should have been. But there was another kind of grief that people were not recognizing, and that is what I call landscape grief, where the landscape, it's grief about the landscape loss. If you lived in New York City, you would miss that landscape element of the Twin Towers. If you live in a mountainous area and all the trees are burned, you grieve the loss of the trees. But one of the things that I got involved in a lot after the Serra Grande fire was recognizing the importance of loss, whether it's a home or the landscape. But for landscape, understand how nature heals and why, and then mobilize the community, which we really did very well there. So the next few slides, I'm going to show you how recovery happens. This is a plot where there was not a crown fire after the Las Conchas fire in June. That's what it looked like in June 2011, right after the fire. This is what it looked like in October 2011. First part of October 2011. Now that area had not had a crown fire. But this is what the blue grama looked like. And this is what it looks like today, just the other day when I was out there. But even in areas that look like this, the people think it's a moonscape. Within a day or two, you start seeing this. It's the most amazing thing. I told you that when the La Mesa fire came, I thought all was lost. Well, a couple days after the fire had gone through my plots, they let me out there. And it was early in the morning. I was standing, and it was dark, and the sun started to come up over the Sangre de Cristos mountains, and the light hit that blackened soil, and what I saw were little spikes of grass coming up. It was one of the most profound moments in my life to realize that out of the ashes, new life was rising. The way plants survive fire depends a lot on the individual plant and what's underground. A fire usually will not burn much further, the heat won't go much further than this. So if anything is below there, it can survive. So this is an oak root. When the top of the oak is burned off, there are these little nodules here. There are certain hormones that keep the shrub from sprouting as long as it has its top. But the minute it doesn't have its top, it stimulates it to begin sprouting. Things like the yucca, which has a rhizome, the wild onion that has a bulb, the dayflower that has underground parts of corm, or the lupin, all of those, they're perennials. They'll begin sprouting within days after the fire. Here are just some of the flowers that can be seen within a very short time after fire. depending on the elevation. Here's an oak. In one of the most heavily burned areas of the La Mesa fire, it was hydrophobic soils. That means the tops of the soil were fused, and yet that was sprouting. Aspen. Aspen is a fire species. This was after one of the fires on Santa Clara. The topsoil washed away, and you can see all the aspen sprouts there. And this aspen sprout comes from those roots that are only about 1 inch under the soil, and it sprouts up, and very shortly you will have, within a month, they'll be over 1 foot tall. In 1 year, that's what the day was. My daughter was about 5th grader. This was at 8 years, and this is at 22 years. This is aspen again. After the Cerro Grande fire, 2000, in October of 2000, this is August, this is July of 2002, July of 2002. Isn't that amazing? To me, it's one of the most amazing things to see how nature comes back. Another way that plants survive fire is through seeds. There are a number of seeds in the soil that need fire to germinate. When a fire comes through, they will germinate. And one of them right down here is called buckbrush. The seeds can lay in the ground for 40 years until a fire comes through, and then it begins to germinate. I did not see buckbrush very often in Bandelier until after the La Mesa fire. Then it was all over everywhere, and it's browsed by both deer and elk. The other one on top is called fetid goosefoot, and it comes in abundance because the seeds. Here's an area with green thread 1 year after the fire, La Mesa fire. There are other conditions that help plants recover. Smoke, for example, will give chemical cues, and the seeds will begin to germinate. This is mullein. It's biennial. The first year, of course, you'll just see the rosette, but then it sends up the shoot. But it is one of those that gets its cues from smoke. One of the problems with fire, of course, is you get exotics coming in. You have firefighters coming from various places, seeds on tires, things like that. So often an exotic will come in, like bull thistle, and replace the native thistles. Another thing that happens after fire is you have this nutrient flush. All this stuff that's tied up in wood all of a sudden breaks down, and then it flushes into the soil. And you get what I call gigantism. In other words, things have lots of fertilizer. This is Indian wheat, normally how tall it is. This is how tall it was after the La Mesa fire, just from that nutrient flux. Here are just some examples of different sizes of leaf. A normal leaf and a leaf on a plant that's been sprouting after fire. There are other things that make a difference in recovery, such as soil crusts. Where you have a very hot fire, often the soil crusts will form first. Those soil crusts will then help stabilize the soil and provide a way for plants to begin to germinate. There are also lots of, this is called a fire fungi that come in and help break down all that wood. Earth stars, slime molds. So I'd like to just briefly talk about rehabilitation efforts. One of the things they did in Los Alamos that was very, very important, and I haven't been able to see this happen many places, is the Forest Service let volunteers out into the forest. I truly believe that you cannot heal from looking at a forest miles away. You have to see those plants sprouting. You have to go out there. What they did is they seeded areas with this little aerial plane. This is what Upper Frijoles looked like after the La Mesa fire up on the top. And this is what it looked like after the Las Conchas fire. The big reason they try and do rehabilitation is this. You get lots of stuff coming down the canyons. However, one of the side effects, well, let me just say, what is seeding do any good? Well, here's an example of an area seeded in 1977 and one that wasn't, versus an unseeded plot 21 years later. They look almost the same. The trouble is you cannot get enough biomass to stop those kinds of floods that happen after fire. It takes years for that biomass to regenerate. But the side effect of seeding is bringing in exotics. Cheatgrass. I very rarely saw cheatgrass early in my plots, and more recently I see cheatgrass. This is another one that's come in, a smooth brome. It came in the seed mix of the dome fire. It's spreading everywhere. It reproduces by rhizomes. It burns off, it just comes right back and it spreads. The problem with this is that Ponderosa Pine has this type of root system, and many of these grasses have very thick root systems, such as this one, which was a sheep fescue planted after the La Mesa fire. These are cool season grasses, same time that the pine seedling is trying to germinate, and so these things can suppress pine germination. This is a very important aspect because when you get people out, it helps them heal. It also helps them have ownership of the area. We had a group called the Volunteer Task Force that planted trees and did different things like that. One of the things we did was we planted germinate pine seedlings. This was on Bandelier. They would only allow this. We germinated the pine seed. We planted the pine seeds. And it was in the 80s, early in the morning. Grew by 1983. They were little tiny like that. The one on the top was a picture with my granddaughter in it, right there, 2009. That's how much those trees had grown. And this, of course, the bottom one, I took just the other day. And this is an area where they planted trees right after the Serra Grande fire, and that's how tall it is now. So there's a little difference in how things react to fire at higher elevations and lower elevations. And just to say that Ponderosa pine is fire adapted. Many of the species that are not fire tolerant are things like pinyon, juniper, and the high elevation trees like spruce fir. So this is where Las Conchas fire burned over Bandelier and a lot of the area. 156,000 acres. But to me, one of the most amazing things, no matter how serious, how hot the fire is, nature recovers. And change happens constantly. We as human beings don't see change unless we look at it from a point of view of a picture. This is one of my plots I set up in 1977 after the fire. This is what it looked like in 1978 because they seeded with slender wheatgrass, which is really a pretty good grass to seed with. By 1985, the trees had fallen down. In 1998, it was primarily little blue stem. In 2010, it had converted to being false tarragon. In June 2011, it burned off. In September 2011, that's what it looked like. So, nature is resetting itself. We've let the forest go so long that we're having these big fires. In 1977, we said the forests were too thick. That's what I hear everybody saying now. 37 years later, the forest is too thick. There are attempts to change this. There's a Hamas Mountain Restoration Project in which they're going to be doing a prescribed burning and thinning in hopes of stopping many more large fires in the Hamas Mountains. But here's an example for you about change, and hopefully it'll give you a little hope. Santa Fe Ski Basin in 1912. Santa Fe Ski Basin now, or it was in the early 2000s. There is new life out of the ashes. But you have to go out and you have to see, you have to look, and recognize that fire is part of the environment. It's inevitable these areas are going to burn. We hope they burn in a cool fire, not a hot fire. And something like Los Alamos that's lost all its trees behind the community, eventually there will be trees there, but not in our lifetime, unfortunately. But I looked to see how many fires were going just today. I looked on the website where they keep track of fires. And could we turn on the light? There are 10 fires in the west. There are 2 in Alaska, 3 in Arizona, 2 in California, 1 in Nevada, 1 in New Mexico. That's the Signal Fire. And 1 in Texas. Of those fires, there's 87,648 acres involved. So, do you have questions? Hopefully I've given you some hope and not just made you feel bad. But what I think is really important is that we all get involved in understanding that the forests need some help. And one of the big issues is drought. And it's going to, more drought you have, the more likely you are to have fire also. So, questions?